Hi, my name is Jack Grubbs, and I'd like to welcome you to my presentation today, investigating the influence of metallic powder handling and storage conditions on flowability and moisture content. Before I get into my presentation, I'd like to thank all of those at Solvus Global, the Army Research Laboratory, and WPI for their continued help in formulating and executing this study. I'd like to begin my presentation by talking about the motivation behind the study, which is based on the premise that in powder-based additive manufacturing, powder properties are critical in determining the success of the AM process. In this study, we looked at dynamic powder properties, including flowability and moisture content. And in particular, we had a focus on how these properties evolved during exposure to ambient temperature and humidity during powder handling and storage. So it was the goal of this study to evaluate the effect of repeated environmental exposure on powder flowability and moisture content for end use in AM applications. In this study, we evaluated two metallic powders, aluminum 5056 and pure tantalum. We conducted a 3-month study, which was full of repeated environmental exposure and characterization according to this experimental matrix here. And through this experimentation, we were able to determine the effects of several parameters on the powder properties, including the effect of material type, number of exposures, exposure duration, and the time of exposure, whether it was directly after packaging or after some time. And we determined these effects through our characterization techniques, where we measured flowability through the Carney flow test method after Hall flow failed, and by looking at moisture content through thermogravimetric analysis, where we measured the mass loss after heating powder to some elevated temperature, which corresponded to the moisture. These are the preliminary results of our study, where we look at both the flowability and moisture content after exposure through the first 12 exposures of our study. And in general, what we can see is some marginal changes in flowability and moisture content as we increase the number of exposures and we look at different exposure durations for both material types. We can see some rather inconsistent trends as we increase the number of exposures and look at different exposure durations. What we could see is a potential for a decrease in flowability and an increase in moisture content as you increase the number of exposures. However, this trend is really not consistent. So what we wanted to do was kind of uncover why we were seeing these inconsistencies and rather unexpected values. So we looked at several influential factors on these properties, the first of which was the laboratory conditions. So we measured the temperature and humidity throughout this study, and what we saw was some small changes in temperature over the course of the study and some spikes in humidity. However, both of these together do not directly correspond to any changes that we saw in flowability and moisture content. So that alone was not the only thing that we could look at. So we went to another factor, which was the particle size and shape. And in this study, we evaluated several size shape parameters, including the spread of the particle size distribution and the presence of fine particles. And what we did see through this preliminary work was that we could expect some inconsistencies in these powder properties, and a future study was really warranted to isolate these specific effects. So in general, what we can say was that we saw some minimal effects of the exposure on powder properties under these standard laboratory conditions. We might see some inconsistencies from particle size and shape, which we'll do a future study to isolate. However, in general, we see that this is a positive outcome for powder handling and storage for additive manufacturing, as we see little degradation of these powder properties with environmental exposure, which can lead to consistently successful AM processing. There are some future avenues based off of this work that we would like to explore, such as looking at more extreme exposure conditions and using alternative measurement methods of these powder properties. However, the main thing that we want to focus is looking at particle size and shape effects, where we want to vary the particle size through mechanical sieving and vary the particle shape by surveying different powders produced by various atomization methods. So we're very excited about this current work that we presented to you and this future work that we're going to explore. If you have any questions, please feel free to reach out. Thank you and have a great day.